Hello, everyone. My name is Gabe Mercy, and I'm an undergraduate computer science student at the University of Minnesota Twin Cities. Welcome to the video presentation for my Undergraduate-Consortium paper, Efficient, Robust Music Genre Classification with Depthwise, Separable Convolutions, and Source Separation. As a broad overview, source separation is a technique that takes a song and decomposes that song into a number of individual audio sources such as harmonic and percussive, or vocals, drums, and bass. The state-of-the-art in music source separation is centered around deep neural networks, which learn a set of masks that are applied to the full song mixture to filter out the individual instrument sources. The goal of this paper is to investigate whether deep music source separation holds promise for encoding new discriminative information during the classification of highly related music genres. The prospect of repurposing a depthwise separable convolutional neural network such that it efficiently applies a filter over each instrument channel will also be evaluated. These ideas are motivated by psychological studies that show that humans decode components of a song when assessing its perceived genre. In addition to this, existing music genre classification methods that utilize some version of source separation tend to focus on sources derived from classical signal processing algorithms such as harmonic and percussive, instead of instrument channels, as is the case when you apply a neural network. The experiment that I conducted assessed the performance of 4 model configurations on a data set of electronic dance music songs across 50 trials. The experiment was artificially constrained by feeding the same data to each model for an arbitrary trial, as well as ensuring that the model architecture was consistent. These configurations included a 1 spectrogram 2D convolution model on the full song, a 1 spectrogram 2D convolution model that did not include the vocal stem, a 3 spectrogram 2D convolution model that operated on the source separated tensor, and a 3 spectrogram depthwise 2D convolution model that also operated on the source separated tensor. At the conclusion of the experiment, 3 main results were observed. First of all, the 3 spectrogram models outperformed the 1 spectrogram models. Second of all, the 3 spectrogram 2D convolution model slightly outperformed the depthwise convolution model when each was compared to the baseline of the no vocals 1 spectrogram 2D convolution model. The main conclusion that was reached is that deep source separation may hold promise for improving the performance of convolutional neural networks on difficult genre classification tasks, and that this may be done so more efficiently with depthwise separable convolutions. Future work will aim to address limitations concerning the dataset size and scope.